Welcome back, students. Let's look at an introduction to E1 and E2 reactions. We've already considered substitution reactions, and now it's time to think about elimination. Let's look at the general idea of what's happening in an elimination reaction. What's occurring is we're removing one group, which is what we're calling the leaving group, which I'm abbreviating here as LG for leaving group. A base is going to come in, it's going to pull off a proton, and you're going to end with a pi bond at the end. In elimination reactions, you're seeing the removal of a leaving group as well as a proton in order to create a pi bond, and that's what makes it an elimination reaction. When we're looking at the elimination reaction, we still have an electrophile, which is going to be our substrate, and that substrate has the leaving group attached. Your substrate is a little bit different than in SN1 and SN2 reactions because what's happening to the substrate is changing. Before, in substitution, you were substituting one group for another. Now in elimination, we're pulling off a proton. The proton that we're pulling off is called the beta proton. Let's figure out where the beta proton is. The first thing I want you to do is find your leaving group. So we're going to find our leaving group, and I'm just going to put a box around that. Remember, your leaving groups are good leaving groups when they are the conjugate base of strong acids, which means they can take on excess electron density. Once you've found your leaving group, go and back up to the carbon that the leaving group is attached to. That's what we call our alpha carbon. And then one carbon away from that is your beta carbon. In this case, you have two beta carbons, but they're symmetrical. So this one is beta and this one is beta. In our elimination reactions, your beta proton is abstracted by a base, meaning a base comes in and pulls off the hydrogen, but it doesn't take the electrons with it, right? So the electrons making the carbon-hydrogen bond, those stay with the substrate. During the course of this reaction, your leaving group also leaves and takes on the excess electron density as the bond between the leaving group and the alpha carbon, the bond I just highlighted in blue, breaks. A lot of the time, your substrates are going to be alkyl halides. Remember that halogens make good leaving groups, with the exception of fluorine. Fluorine stinks. Horrible leaving group. So when we're looking at your alkyl halides, remember, we will find our leaving group, we back up one atom, that's your alpha carbon, here's your beta, and if you want to get crazy, there's your gamma. In this example, you have a different beta carbon on the other side, and so you actually have two different beta locations. And I say different because unlike the last molecule that was symmetrical, this molecule is not symmetrical. So these really are protons that are in different environments that if you abstracted one versus the other, they would give rise to different products. Let's look at a quick overview of the E1 versus E2 mechanism, and then in other videos, we'll go deeper into those mechanisms. First, let's look at the E1 mechanism. In your E1 mechanism, this is, again, like SN1, a unimolecular reaction, which means that you have one molecule in the rate equation. What will occur is the leaving group will leave first on its own and create a stable carbocation. So your first step is your leaving group leaving, then a base will come in and pull off the proton. When the base comes in and pulls off the beta proton, the electrons in between the beta proton and the beta carbon swing around and they make a pi bond. So we have two steps here, loss of leaving group and a proton transfer. These two types of arrow pushing are happening at two separate locations or two separate times, where first the leaving group leaves, step one, step two, there's a proton transfer. In your E2 reaction, you still have the same types of arrow pushing patterns. You still have a proton transfer and a leaving group leaving. The difference is that in E2 reactions, those things are happening simultaneously. Remember, we called that a concerted reaction, whereas the E1 reaction that happened in more than one step is a stepwise reaction. For E2, your base is attacking the proton, and those electrons in that bond are swinging around, creating a pi bond and pushing out your leaving group. So your leaving group is leaving. In the reactions I've drawn here, I've illustrated the reaction using the same compounds and drawing the same products, but realistically, when you start looking at examples, it's either going to be the E1 mechanism or the E2 mechanism. So what we need to do is dive deeper into the E1 and E2 mechanisms to figure out which one is going to occur and how that affects what your products look like. Let's wrap up. In this video, we introduced ourselves briefly to elimination reactions, where we saw that in order for us to have an elimination reaction, you need a base that's going to remove a proton, and you need a substrate that has a good leaving group. Your substrate's leaving group will leave, and the base will abstract a proton, and in the end, you'll get a pi bond. Remember that your substrate is what contains the leaving group, and that halogens make good leaving groups with the exception of fluorine, which stinks. Then when we looked at the two mechanisms, we saw that your two steps of these reactions could happen at the same time, which would mean this was a reaction that was concerted when your base is pulling off a proton and your leaving group is leaving, and that's happening all at the same time. Or your leaving group could leave on its own in one step, and then in a separate second step, your base can abstract a proton. In that case, the reaction would be stepwise, and that's an E1 mechanism. Let's dive into this some more in another video. Thanks so much for watching. This is Katoni signing out.